Welcome to another small problem session. So this is another standard problem. A car is rounding a bend in a road, and it can be flat road or it can be banked road. Banked road is like you have a one edge is higher than the other edge and the angle is theta. So of course this one is basically this case is same. This case is same. This is same with theta equal to 0. So we just solve this. Okay. The question is, what is the critical value? So what's the critical value of this speed if it's going to bend at a constant speed? So over here there will be a safe speed marking. Okay, safe speed marking. So you can see you are above you, below it, and what the safe means. Okay, so the question is, what is the safe value for V? I'm not going to use V2, just use V. Okay. What's given is when the car is rounding a bend, it's not this circle that matters. It's the circle that it will be if you were to think of this as kind of like a long funnel, and the road is up to only this much, and in this funnel you will be kind of doing that big radius. So this will be the R. It's the circle in which it's going. So this is a good picture here. So rather than do three-dimensional, look at a cross section, that cross section. Okay, that cross section. So if you look at, that's the cross section. So that part is the road, and you can keep going. Of course I've exaggerated the banking angle just to make clear. So this is where my car is not sliding. So car is not sliding. So safe will mean not sliding, will mean no kinetic friction, yes, static friction. So this is how decide the static friction will play a role. Okay, so let's look at the forces. So one force is of course gravity this way, mg, less mass of the car be m, and another force will be 90 degrees to this. It's just like a ramp, things on a ramp, right? So it's going to be 90 degrees to that, and that's going to be the normal. And the static friction is the static friction this way or this way. We got to decide which way to put so that we don't run into negative positive sign. So the way we decide a static friction is, well, if there was no static friction, which way the car will go? Car will go that way. It will veer. This is the speed, this is the velocity, and the car will just go out like that. If there's no static, car is not going to slide down by speeding. Now if the velocity was zero, and no static friction, then car will slide down like that. But velocity is very high, that sliding will occur that side. The static friction will be down below. So depending on the situation, static friction one way or the other. So static friction here, we're going to say static friction is here, and so we want the friction car to use the maximum static friction. So we want that, and this will all of this is going to be acceleration will be v square over r. That's the acceleration it causes, all of this. Well, we are going to use this kind of fixed coordinate system. So we're going to use inertial x, o, y. We don't need x, y here, just need the direction. So that's the direction of our coordinate system. So I keep the coordinate system. The acceleration is I drew at a time where the acceleration is along the coordinate system. So this is along the x-axis and this along the y-axis. So if this was theta, so you already practiced a lot, this angle will end up theta because this is 90 degrees minus theta, this is theta, this is 90 degrees. So this becomes theta. I just noticed my highlighter is not on. Let me turn it off and turn the highlighter on. The highlighter is on, so I can actually, you can see where I am. Okay, so that's the theta. Okay, there. I hope it's worked out good. Theta. So along the x-axis, I'm going to have this guy. Let me get this guy and this guy. So this is theta. So this is also theta. So they will have x components. All of them x. X-axis will have n sine theta plus fs max cosine theta equals to mv square over r, and on the y-axis will have n cosine theta. Even this guy is going to have y-axis component, that much, minus fs max sine theta minus mg equal to 0. So you can see that if there are two equations here, this one will simply be mu is given, mu s n, because it's max, so mu s n. So this seems like I can solve for n, and plug into that, and that should give me the v. That's my strategy. Okay, so from the two I'm going to get n cosine theta minus mu s sine theta equals to mg. So n is going to be mg over cosine theta minus mu s sine theta. So plug into 1 has n sine theta plus mu s cosine theta cos m v square over r, and I need v, that's the question. So n over here, that give me mg over cosine theta minus mu s sine theta, and then you have this stuff here, sine theta plus mu s cosine theta equals mv square over r. M cancels out, r on the other side, and you have a square root. V is speed, means keep the positive square root. So it's positive square root g r, and then you have a ratio of this sine theta plus mu s cosine theta over cosine theta minus mu s sine theta. So that's the answer. So let's see what happens when you have a theta equal to 0, flat root case. So that was v1 squared gr 0 plus mu s 1 minus 0. So this will be square root mu s gr. So even in a flat road, you have sufficient friction, you should be able to drive around at a speed less than this. Okay. Of course, for different angles, you're going to get different values for v. All right. So this is the more complete answer. Okay. So I'm going to stop here. Just wanted to advertise this channel. Hope you could subscribe to this channel. Okay. And if you like this kind of explanations, hit a like button. That helps distribution with this material. All right. Take care. Bye.